Teacher knowledge and behavior is the component of the model that focuses on teachers' knowledge of students and content and on their expertise in classroom management and pedagogy. Teacher knowledge is the element of teacher knowledge and behavior that encompasses knowledge of student characteristics and teachers' in-depth content knowledge, and the blending of these to enhance learning. More information on this can be found in the Technology as Facilitator of Quality Education model. The students in this 8th grade science class are learning about weather. Working in pairs, the students construct a model to represent their understanding of the cause and effect relationships between the weather concepts they have studied. The teacher demonstrates knowledge of student characteristics by encouraging the students to use their interpersonal intelligence. Working with a partner enables students to interact while learning.
Okay, let's actually try and figure out a way we can actually explain this.
Doesn't the time of day affect the temperature?
Yeah.
So we should have a relationship between
In the morning, the temperature is low. In the afternoon, the temperature is weak. And at night, it's high.
Okay, time of day affects the sunlight, because there's sunlight in the
Yeah, but it already is.
high. And then when the sunlight, it gets hotter when the temperature goes up, and when the temperature goes up, the chance of rain goes up. Wait, no,
Necessarily.
goes down.
No, not necessarily.
Yes, because when
There's no bearing on the temperature. There's no bearing with the temperature.
yes, because when it gets colder, relative humidity goes up, and when relative humidity goes up.
And to G weather,
So should we start by
G
making
weather
a,
model it.
See, the
Between
temperature goes there, and once the relative humidity goes down, the chance of rain goes up.
So it does or does not make sense.
Makes okay
G
sense.
But
There's
weather
huge
model.
holes
It's
in
in
the thing, but
Easy
that's
so should we make a relationship between these two?
Oh yeah, let's put it in.
no. There's already a
You
relationship.
mean it's not on the
Between time of
desktop?
day and temperature?
Yeah,
let's
because
get
time
that
of
on
day,
the
there's
Oh, yeah.
more sunlight, and when there's more sunlight, it goes to temperature.
Just transfer it over there.
One sec.
The teacher shows knowledge of student characteristics by addressing her students' logical, mathematical intelligence. The students use Model It software to show the qualitative relationships among weather variables in order to create a weather prediction model that makes sense.
If you have high pressure, the pressure gets high, and then also the precipitation goes up higher. I mean, goes lower because
Same with the clouds.
and the clouds go lower because in high pressure you can't have clouds or
You can't evaporate
or
water.
humidity because you need low pressure to have humidity. So the clouds and the yellow is the precipitation
And the green is humidity.
yeah, so they both go low. And if you lower it, they sort
Does
of
that.
switch
Yeah.
because they're inverse relationship. And the humidity and the precipitation goes high if we lower the barometric pressure.
So if you lower barometric pressure, then you have more clouds, and because of more clouds, more moisture.
Yeah.
Okay.
Alright, then if you raise the amount of sunlight, what's going to happen is the wind's going to raise, because by raising the amount of sunlight, you raise the heat. It makes it more uneven, like the heating and cooling, which will cause wind.
So the pink is the wind, and it goes up higher when you raise the sunlight and the heating and cooling.
Okay, that makes sense, because what did we say? We said that wind, one of the things that cause wind is...
uneven heating of the surface of the earth.
Sure, because the earth wants to do what? It wants to...
Be equal.
Be equal, right? Equal pressure and equal temperatures, okay?
The teacher's in-depth content knowledge is evident in her method of instruction. She uses questioning to get the students to verbalize their thinking process as they create their weather prediction models.
Where is an area where we don't have much wind?
The doldrums of the equator.
Okay, at the equator. And why might that be?
Because the sun always, since it's in the middle of Earth, the sun shines on it an equal amount of time throughout the year. So it's pretty much getting an equal amount of heat each day.
So there's very little variation. Oh, great. All right, any other factors? All right, that looks good. Does anybody have any comments?